everyone. In this video, we're going to determine the GCF of a given algebraic expression. Now let's define GCF first. GCF is an acronym that stands for greatest common factor. By definition, this is the largest expression that can divide evenly into two or more expressions. Let's take this first example right here. Find the GCF of 21x plus 14. In order that we can find the GCF of this, we need to follow some steps. The first step is to break down the terms to its factors. So I can go ahead and rewrite that down here. Okay, so we are going to determine the factors of each of the terms. So we're going to start with 14. You can start with 21x, that should be fine, but let's start with 14. So the factors of 14 would be, we can have 7 times 2. So I go ahead and write 7 times 2. And then we factor out 21x. So I'm just going to go ahead and write that on the side right here. So the factors of 21 would be 7 times, it's not a 2 because that would just be 14, but 7 times 3. Now notice that I put the 3 not in line with the 2, so that it's easier to determine which ones are the common ones. So 7 is common to both of them. So again, I put the 3 here. This is pretty much the same thing. So 7 times 3 is 21, and there's an x after that. So I'm just going to put the x right there. Now, after this, we are going to move on to the second step. The second step is to determine the common factors. So out of these factors that we got, we need to determine what's common to both of them. So let's start with 7. So 7 is common, so I can go ahead and circle that. So there's one group of 7, so I can go ahead and say that the GCF here would be 7. And then let's look for the rest of them. Now, 2 is not common to both of them. It's only for 14. And 3 is not common to both of them because 3 is only for 21x. And x is not common to both of them since x is just only for 21x. Again, we're looking for the greatest common factor. So we're looking for the common factor. So only 7 is the common factor. So we go ahead and say that the GCF for this is 7. Now let's move on to the next example right here. So we have 8x squared minus 12x. So again, we follow the steps in order that we can determine the GCF for this. The first step is to break down the terms to its factors. So I'm just going to go ahead and rewrite that down here. Okay, so we break down the 12x first. So I'm just going to go ahead and write that on the side here. So the factors of 12x would be 3 times 2 is 6, and then times 2. So 3 times 2 is 6, 6 times 2 is 12, and then we get an x. So I'm just going to put an x right here. So these are the factors of 12x. So if we multiply all these 4 monomials, then it will come out 12x. Now let's have the 8x squared. So I can go ahead and factor the 8x squared here. That would be 3 is not a factor of 8. So, but 2 is. So 2 times 2 is 4, and then there's another 2. So 2 times 2 is 4 times 2 is 8, and then there are 2 x's after that because that's x squared. So these are the factors then. So we can go ahead and say that 3 is not common to both of them. Again, we're looking for the common factor. 3 is only a factor for 12. So but 2 is a common factor. 2 is also, another 2 is a common factor here. We also have an x, which is a common factor. So we can go ahead and say that the GCF for this would be one group of 2. So I write 2 here. And another group of 2. So I'm just going to write another 2. And then one group of x. And then I'm just going to write x. So 2, 2, and x, which gives us 4x. So the GCF for 8x squared minus 12x is actually 4x. At this time, I would encourage you to pause this video and try this problem out on your own. And when you're done, unpause it and check your answer. Okay, we go over the problem here. Again, the first step is to break down the terms to its factors. I'm just going to show the work down here. Okay, so I've factored out each of the terms. So we're going to move on to the second step. The second step is to determine the common factors. So 3 is a common factor to all of these 3 here. 5 is only for 15. 3 is only for 9. This 2 here is only for 12. But then we have another x here which is common to all 3. So what are we doing here is we're looking for numbers or variables that are common to all 3. It's not only common for 2 or it has to be to all 3 because the x here is common to both 2 only, but it's not common to the 15. So then we go ahead and say that the other x here is not a common factor, but these 3 x's here are. So then we go ahead and say that our GCF for this would be one group of 3 and then one group of x, and that's it. So we go ahead and say that the GCF is actually 3x. So I'm just gonna put this inside the box. Now, did you get the same answer as this? 3x? Good, perfect. Now let's move on to the next example right here. So we find the GCF of this algebraic expression. So again, we have the same step. The first step is to break down the terms to its factors. So I'm gonna go ahead and show the work down here. Okay, we move on to the second step. The second step is to determine the common factors. So the common factors here would be 2. Then we have x right here. So this first group of x, this second group of x, and this third group of x. And then we also have a y here. So the other y right here is only for this term. So then we go ahead and say that the GCF here would be first group of 2. And then we have a first group of x, another group of x, and then another group of x, and then another group of y. So then the GCF is 2x to the third power and y. So this is our GCF for this expression that we have right there. At this time, I would encourage you to pause this video and try this problem out on your own. And when you're done, unpause it and check your answer. Okay, so we're gonna go over the problem here. Again, the first step is to break down the terms to its factors. So I'm just gonna go ahead and rewrite this down here. Okay, so I've broken down each of the terms to each factors, and so we are now ready to move on to the second step. The second step is to determine the common factors. So from here, we can go ahead and say that 5 is common to all 3, and then our A is common to all 3 here. These 2 A's here is only for these 2 terms, and then we also have a B and another set of B. So then we can go ahead and say that our GCF would be one group of 5 times another group of A, and then another group of B, and one group of B. So then we can go ahead and say that the GCF is 5AB to the second power. So this is the GCF for this expression that we have up there. Did you get the same answers as this? Good, perfect. If you find this video helpful, hit like and subscribe for more math videos. See ya!